Hey folks, thanks for joining me in this video. We have been talking about what happens when we have two parallel lines in a transversal. We've looked at our angle pair relationships. We've looked at corresponding, alternate interior, alternate exterior, consecutive interior angles. Today is going to be a converse day. That's right, grab your sneakers. Okay, that was a bad joke. What's a converse again? Been a little while since we've talked about converse, but if we have to take our if and then, right? Remember our if then? How do we get the converse? Take the if then and switch it. So let's apply the converse to what we've been learning. So we have our corresponding angles postulate. What does it say? If the lines are parallel, then corresponding angles are congruent. Let's take the converse of that. If corresponding angles are congruent, then the lines are parallel. Good, look at that. I knew you guys would catch that right away. Let me show you a little demonstration of that. I've got GeoGebra open. I have two lines. I have a transversal. These angles we would recognize as being corresponding angles. Are they congruent? No, they're not. Are the lines parallel? No, I see them intersect over here. What happens though, as I take and I change my angle here, oh, I had it a second ago. There we go. So that the corresponding angles are now congruent. What's true about these two lines? They are parallel. So go ahead and open your notes, please, if you haven't done so already. Find postulate 16, our corresponding angles converse. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So note a couple things here. Look at lines J and K. Look at angles 2 and 6. They're corresponding angles, they're congruent, so what's our conclusion? J is parallel to K. Find the value of x that makes line M parallel to line N. So just to make sure that we understand the question, we want to find the x value that makes the lines parallel. We don't know they're parallel. We want to find the value of x that makes them parallel. So for example, if x was 10, are the lines parallel? 2 times 10 is 20 plus 3, that's 23 degrees. Would that make the lines parallel? No. We know if corresponding angles are congruent, then the lines are parallel. This is only going to happen when 2x plus 3 equals 71. So subtracting 3 and dividing by 2, when x is 34, the lines will be parallel. Check it. 2 times 34 is 68 plus 3. That makes this angle 71. If both of those angles are 71 degrees, then the lines are parallel. So you would expect, hopefully, what's coming next. If we have a corresponding angles converse, we might also then have an alternate interior angles converse, an alternate exterior angles converse, and a consecutive interior angles converse. Let's see what each of these say. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. If two lines are cut by a transversal so the alternate exterior angles are congruent, look at 1 and 8, alternate exterior angles. If they're congruent, then the lines are parallel. If two lines are cut by a transversal so that the consecutive interior angles are supplementary, 3 and 5 are consecutive interior angles, they're supplementary, that means then the lines are parallel. So we're going to spend a lot of our time in this lesson looking at Is there enough information for us to determine the lines are parallel? If there are, can we prove it? Can we show that two lines are parallel? Okay, I've got 3 diagrams up here next. And the question is there enough to know that these lines are parallel? Look at lines P and Q. Okay, first example on the left. Okay, do we know that line P and Q have to be parallel? Well, what do we notice? We notice we have two 60-degree angles. Those angles are congruent. What kind of angles are those? They're alternate interior angles. And what do we know? If alternate interior angles are congruent, then the lines are parallel. So we would say yes by the alternate interior angles converse. All right, middle one. I notice that this angle is marked congruent to that one. Is that enough for us to know line P and line Q are parallel? Well, is this one of our special pairs? It's not, is it? They're not corresponding. They're not in the same position. That's top right, that's bottom right. They're not alternate interior. They're not alternate exterior. They're not consecutive interior. This is not one of our pairs. But we still have to do a little bit more thinking, because maybe even though it's not one of our pairs, maybe the lines still might be parallel. So how might I think through this? Well, I might get a little bit more concrete and pick an angle measure to think about this a little bit more. Let's say this angle was 60 degrees. Well, if this angle is congruent to it, it's also 60 degrees. If those two angles were 60 degrees, would those lines be parallel? Well, it would look kind of like this then. What's a 60-degree angle look like? 60 degrees roughly right there. Okay. Now I need that angle to be 60 degrees. Be roughly like this. Those angles are congruent, 60-degree angles. Are these two lines, P and Q, parallel? No, they're not. We can see that they intersect. So sometimes it's helpful for us, when we're not given an angle measure, to actually pick one and really visualize what that would look like. Now, could they be parallel? If these are congruent, could they be parallel? Sure. If they're both 90 degrees, if that's 90 and that's 90, they would be parallel, wouldn't they? Because then I could use a linear pair to figure out that that's 90. Now I have alternate exterior angles, which are congruent, which makes the lines parallel. However, do we know that those angles have to be 90 degrees? No. Could they be 89? Could they be 88? Yeah, we're not sure. So, is that enough to know, to prove the lines are parallel? No. When we picked that 60 degrees, we found a counterexample to that. The answer to this is no. How about these two? Okay, we got line P, we got line Q. We have two angles that are both x degrees. Well, if that's x degrees and this is x degrees, that means they're congruent, aren't they? What kind of angles are those? They're corresponding. If corresponding angles are congruent, then the lines are parallel. So this would be a yes by the corresponding angles postulate. Nope, not the corresponding angles postulate, the corresponding angles converse. Okay, and I didn't even mean to make that quick mistake there, but it brings up a good point that we're going to talk about in a minute anyway. Okay, we have the corresponding angles postulate, and we have the corresponding angles converse. We have to keep track of which one we're using. One of them says if the lines are parallel, then corresponding angles are congruent. The other says if corresponding angles are congruent, then the lines are parallel. We have to know, are we trying to show that the lines are parallel? Okay. If you look back, that's what we're trying to do here. Prove the lines are parallel. What do these three and that one all end with? Then the lines are parallel. Those are the converse. So if you're proving the lines are parallel, you're using the converse, not the original postulate or theorem. Speaking of proof, here we go. We've got one proof to wrap up this lesson. We're given that line A is parallel to line B and angle 1 is congruent to angle 3. We want to prove line X is parallel to line Y. All right, let me think through this a little bit before I even write anything down. A is parallel to B. Let me mark that. 1's congruent to 3. Let me mark that. I want to prove X is parallel to Y. X is parallel to Y. Well, here's what I'm thinking. I'm thinking that I have two lines here, X and Y, that are parallel, that aren't parallel, that I want to show are parallel, and I have this transversal. Would you agree if angle 2 is congruent to angle 3 that X and Y would be parallel? Yeah, they're alternate exterior angles, aren't they? So what I want to be able to do is I want to be able to show that angle 2 is congruent to angle 3, because then I've got it. What do I have right now? I have A and B are parallel and 1's congruent to 3. Well, wait a second. If A and B are parallel, what do I know about angles 1 and 2? They're corresponding angles. They're congruent. If the lines are parallel, then corresponding angles are congruent. So 1's congruent to 3. By corresponding angles, 1's congruent to 2. I think we've got it. Let's put this together. So I'm going to start with A being parallel to B as the given. If A is parallel to B, then 1 is congruent to 2. Because they're corresponding angles. Now we have to be careful. Is this the original corresponding angles postulate, or is it the corresponding angles converse? Well, what are we saying? We're saying if the lines are parallel, then corresponding angles are congruent. Is that the original or is that the converse? That's the original, isn't it? Okay, this is the corresponding angles converse. Alright, so 1's congruent to 2. Let's not forget that 1 is congruent to 3. That was given. If 1's congruent to 2 and 1's congruent to 3, then 2 is congruent to 3. There's one of our favorite properties, the transitive property. Now, let's double check where we're at. We have angle 2 congruent to 3. We want to show line X is parallel to Y. Notice 2 and 3 are both formed by this transversal, and 2 and 3 are alternate exterior angles. If the alternate exterior angles are congruent, then the lines are parallel. X has to be parallel to Y. Alright, now again, is this the original or is this the converse of the alternate exterior angles theorem? What are we saying? If the angles are congruent, then the lines are parallel. Then the lines are parallel. This is the converse, isn't it? This is the alternate exterior angles converse. So, okay, it's not really new information. It's just using it in a different direction. Okay, we have all of our originals. We have all of our converses now. We can go back the other way. We're still proving things. This time we're proving that lines are parallel. This is where I'm going to wrap up the video. I'm going to let you guys get to your practice. Thanks for tuning in. We'll catch you next time.